Hello, hello, hello. 18. Numbers are a little low today. Oh, that's sad. Oh, well, the important people are here. Hello, everybody. Hello, Sharon. Hello, Hunter. Hello, Lucy. How are you guys all doing today? Kennedy, hello. Sam, hello. Hello, Emily. Breeze here. That's good. Excellent. Excellent. That's good. Yeah, again, I haven't, I've been told there are ways to check attendance and stuff in Blackboard. I haven't really felt the need to do that yet. Hello, Maddie. And Madison. Hello, Lindy. Hello, hello. Abby, hello. Oh, look, there's more than I thought here. Okay. Or maybe just all 18 people have said hi. Okay, so again, hopefully you guys are doing okay. I really haven't felt the need to go into Blackboard and see that you're checking in every day. I know that you guys have to check in using your Tiger ID. I know, we'll see where things shake out, I guess, Hopefully these videos are giving you a second take at some of the information in the original videos. I think this new stuff is pretty good. But anyway, so here we are. So let's do some housekeeping first, and then we shall Kahoot. Alexandra, hello. Mayron, hello there too. Hey, listen, if you emailed me after 3 o'clock yesterday and said, could you look over my Stoic? I didn't. I apologize. I was doing other stuff. And then I had to work on the Kahoot for today. But if I see anything, glaring, I mean, if you've submitted it on time and I see some big mistake, I'll let you know and let you correct it. I've looked over about 10 of them so far. And they're good. There's most of the mistakes I've seen are just people making sig fig mistakes. And at this point, it is what it is. But I think most of the people are setting up their problems well. You're doing a nice job solving the grid and things like that. So if somebody's helping you do that, that's fine as long as you are doing the math. So that's great. So I've started to plan our next sort of meaningful assessment. It will be due after spring break. It'll probably be some kind of timeline of modern atomic history, but more details to follow. So we got some housekeeping stuff here. Let's see what we got here. I like Lucy's multitasking. So again, one of the things I did do last night is I did go into Pearson, and I just kind of assumed that we're going to be out for April. Actually, I went, and so I just said, okay, let's pretend that we're out for all of April. I don't know if we are or not. I guess, we'll see what we end up doing there. Tanae, hello. Good to see you. Hey, Abby. And so I thought I would just go ahead and kind of mock out Pearson for the rest of the month. I have not updated the weekly assignment sheet yet, but the Blackboard calendar is updated. The long-term calendar is updated. So just assuming, for those of you who want to work ahead, I'm just sort of working out where all this content's going to be based on our sort of routine that we have right now. I actually mapped it out for the rest of the year on the long-term assignment sheet, just in case. And if all we do is cover content and have Friday reviews, we'll be fine. We'll have the last week to do whatever we need to do before we do finals. And so I just looked at the worst case scenario that we're out for the entire year. Again, I don't have any insider information on this, but we could do what we're doing now and get through all the content. It is what it is. Obviously, if we go back to school, then we'll shift, but these quizzes are still going to need to be due anyway, so you'll be fine. So please check out Pearson. I've got them updated for April, and I will go beyond that at some point. I will be posting the new weekly assignment sheet today. Again, you can see all that stuff on the Blackboard calendar or the long-term assignment sheet or Pearson. But I will, I'll put it all together into the weekly assignment sheet this afternoon with some good enrichment links for you. Again, I am going to close down the third quarter today in terms of points. I will still obviously be calculating, and if people have some missing work, we have a day or two next week to get that taken care of. But as of today, the assignments that we're due today will encompass the third quarter. Probably not the Stoic assessment itself, though. It'll be the other stuff. I did push some other stuff back, too, to next week. So if it got pushed back to next week, it won't be part of the third quarter either. We'll figure it out. And again, I will try to this weekend work on grades and kind of put up what I think your third quarter grade is. And that'll give us a couple days to play with that if we need to. So again, most of you have most of your stuff in, especially if you're showing up to these sessions. But again, if you're worried, just email me. Again, after 3 o'clock, I tend not to get to email very quickly, but I will get to it at some point this weekend. All right, so let's see. I think we're ready. I think that's all the announcements. Let's see if there's anything in the chat I need to take care of. Yes, we have some alumni here. Now, alumni, I warn you, I've taught them new information this year that I did not teach you in the videos. So you might be at a bit of a disadvantage. Oh, I haven't emoted at all. Here we go. I'll emote here. Sorry about that. I didn't emote. I was paying attention to my content. There's some emoting. All right, so here we go. We're going to try this out here. Let's see. I'm going to switch to this. Yes, Lucy, your photo is still up. Let's switch to Kahoot. Hide that. Fade. Hey, there we go. All right. I think that worked. I think I can still be in the picture. If I'm blocking the answers, just tell me and I'll get out of the way. But I kind of want to be part of this too. Also, for those of you who played next week, I think oh, it's Sam's birthday. Is it really Sam's birthday? Sam, is it your birthday today? Sam. Yeah, I guess it'll just be me, but I'll do it. Okay, how old are you turning today, Sam? 16? All right, I'll do rockets for everybody. Okay, this is just me alone. Ready? Sam, what's your word? I'll wait for your word, Sam. 16. Okay, good. And what's your word of the day? What's your chemistry word, Sam? We'll wait for this. Sorry for the delay, the latency delay, waiting for Sam's word. I'll just start. I'm going to start the rockets, and Sam, just tell me what your word is by the end. Okay, ready? So here we go. I'll try to emote my way through this. Ready? 4. Oh wait, I did that wrong. 8. This is kind of 12. I like that word, Sam. Here we go. 16. Quantum mechanics. Yay. All right, that was Be by myself. All right, okay, I think we're ready to Kahoot. There you go, Sam. Congratulations. You got the first virtual Kahoot. It's going to go huge. Spread the word. Rockets. All right, so here we go. So we're going to do classic mode here. Classic mode. Oh, thank you. Thank you for joining in. Thank you. I appreciate that. All right, I think we're ready here. Let's see, make sure everything's okay. All right, we'll do classic mode. Okay, I think this is it. And I think I set it up. You guys should be able to hear the music now. Can you hear the music? I think you can hear the music. I think I did some technical finagling here. I'm going to turn that down just a little bit. I don't know how loud that is for you, but... And with Kahoot Premiere, I was able to pick out my own music. So I picked out jungle music from their selection because I'm a free Kahoot Premiere member now. I'm a super user. All right, so there are 27 people in the chat. I will wait till we get to about 25. Yeah, I picked jungle theme. I did. I picked jungle theme. I feel like they rip off people's songs a little bit. I feel like this is another Peter Gabriel song, but... All right, we're up to 25. I feel like everybody's here. I'll wait like another 15 seconds just in case. Uh-oh, Sharon. Try again. We'll wait for Sharon. Hold on, we're going to give Sharon one more chance. Or else we'll just have to play at home. Play along at home. This is only 20 Kahoot questions. How long could this take? Any luck, Sharon? Oh, we lost a player. We're down to 24 now. All right, I'm going to count down from 20 in my head. I'll do some emoting here. Go on without me, Sharon. How noble of you. All right, okay. All right, well, you can play with Hunter, I guess. You guys can. All right, so let's get started. Here we go. I'm proud of you, Sharon. All right, here we go. So this is just covering Einstein and on. Here we go. Question 1 of 20. So which of his Annus Mirabilis things did he win the Nobel Prize for? All right, so if you watch the Einstein video, you know this. And thankfully, there's no one shouting out the correct answer in the classroom anymore, so that's one benefit of remote learning here. Oh, Luke, what? I'm sorry, I missed you, Luke. Hello, Luke. Yeah, you might think he won a Nobel Prize for special relativity. He did not. It was actually the photoelectric effect. So again, some of these questions actually deal with that. No, stop it. Don't shout out the answers in the chat. Yeah, so it was actually the photoelectric effect. Stability. Hey, Oakleaf is here. All right. Oh, man, we got a celebrity in the house. Man, a YouTube celebrity. Hello. She's got a collab in the pandemic here. Yes, so that's correct. It's the photoelectric effect is what he won the Nobel Prize for. All those other things are things he did do when he was like 25. These are all like groundbreaking things in science. But it was the interpretation of the photoelectric effect is what got him the Nobel Prize. All right, so what's next? Let's see who's doing well here. Amazon Rhino. Oh, we got a lot of people holding in there. Okay, here we go. Stability is always the answer. Correct, Oakleaf. Electrons are only emitted by certain materials when the light exceeds a threshold. Brett, too, man. This is more alumni than students, I think, officially. This is nice. So what does it need to exceed? What threshold to get a electron being emitted? I'm going to work out here. I'm going to do some workouts, some arm lifts here. I got to add some new emotes. Very good. Nice job. That's nice. Very good. Yes, frequency. Yeah, it doesn't matter the intensity of the light or the duration of the light. Obviously, the speed of light's all the same in a vacuum, but it's the frequency that determines whether or not an electron will be ejected. Very good. Nice job. Oh, nice job. By the way, I shared a link to the that tweet that you worked on, Luke. I thought that was pretty funny with the discipline in remote learning. That made me laugh. I appreciated that. All right, Sri, stop giving away the answers. All right. Here we go. This is our next. All right, look at this. Premier Kahooter. Einstein proposed that light was actually composed of... Well, at least my alumni are having a good time. I don't know where my students are. Wow, nice job, photons. Man, this is Oakleaf. We'll see, buddy. I think you are going to struggle with some of these. You might be eating those words. But yes, it is photons. Very good. Very good. All right, so... Tui. Oh, Nico. All right. Man, it's like period 7's back again. We should have a survey. I wonder if there's ways to do surveys in Yahoo. I mean, Yahoo. Not Yahoo, YouTube live streams. Anyway, Einstein proposed that the wave-particle duality of electromagnetic radiation, is that true or false? This is only worth 1,000 points. So did Einstein propose the wave-particle duality of electromagnetic radiation? True, he did. Einstein proposed this, yes. More of you missed that. But yes, Einstein was the one who proposed the wave-particle duality of electromagnetic radiation. That's the reason why the photoelectric effect was such a big deal, because to explain that, light need to be acting like both a wave and a particle to do that kind of stuff. So that's okay. We're all learning here. This is light assessment. All right, here we go. Lovely Meekrat is in the lead. Decisive Sphinx. I forgot to pick a winner here. Man, this is a tight race here. The Giving Yeti and the Bold Goat. Great names, great names. Here we go. Let's see how we're doing here. Let's see. Who is given credit for the planetary model of the atom? It's a deep cut way back. Let's see if you guys know this. Oh, very nice job. Yeah, Rutherford got the original planetary. Very good. Very good. Yes, that is correct. Yeah, I didn't think that one was going to be too hard. All right, so let's move on. Yes, Rutherford made the planetary model. Now, remember, the reason we still teach the planetary model is that it's our last really visual model of the atom, right? After that, everything became really mathematical. So there's still something useful about the planetary model. It got a lot of things right. I mean, there's a nucleus and electrons are on the outside. So, you know, that's not terrible. All right, let's see. Uh-oh. Look at that. Kind Lizard, Decisive Sphinx is up there. Dr. Lion. Hello, Doctor. Thanks to all of our doctors out there. who quantized Rutherford's model of the atom. I don't hear my alumni saying this is too easy now. Will they get it right? Will they get it right? Very good. Yeah, I thought you guys might bite on Planck there. Yeah. Planck did come up with the idea that energy needed to be quantized to explain black body radiation, but it was Niels Bohr who took Rutherford's model and then corrected it due to using like discrete energy and quantized principles. So it was Bohr that fixed it up. In fact, that's why it's often called the Rutherford-Bohr model of the atom. So anyway, let's see if that oh no, lovely Meekrat took a hit, but Dr. Line is up to the Amazon draft. This stream not sponsored by Amazon, but let's see. Oh, Lucy, congratulations for being on the podium. Bohr's atomic model allowed electrons to exist at any distance from the nucleus. True or false? Oh, Emily's talking some trash in the chat. Good, exactly right. Yes, Bohr's atomic model did not allow electrons to exist at any distance. Very good. That's a very good that you guys got that correct. Yeah, so that's false. The electrons needed to only exist at certain allowed energy levels. And now Bohr didn't quite understand why, but we'll see what happens from there. Oh, Dr. Line slips kind lizard. Very good. Kindness is very important right now. So congratulations, kind lizard. All right, let's see. Luke, I haven't forgotten about our side project. I haven't. I know you think I have. I have not. See, I'm working on my character animator skills right now. Anyway, which Swiss mathematician first calculated hydrogen's spectral lines? Normally, I'd be doing my little dance in front of the Active Inspire board. I'll try to do my little dance here. People always said I danced like a Muppet anyway. Very good, the Balmer, Johann Balmer. Yes, Balmer. Nice job. Okay, good. Nice, you guys are paying attention. And again, we're going to keep this real conceptual. If you want to dig into the math, that's what, advanced math is for. Kind Lizard still in the lead. Bold Goat's making a move for it. Good. Okay, we got a pretty consistent top 5 here. All right, true or false? Here we go. Johann Balmer's equation was an improvement over the limited Rydberg equation. Yes. This is only my people who attended the live stream are probably going to get this right. Well, you have a 50-50 chance. So in Premiere Kahoot, you can also get free images here. Oh, look at that. Most of you got that wrong. Yeah, so Johann Balmer was first. He came up with a mathematical explanation of, not even an explanation, a mathematical description of hydrogen's bright lines. Rydberg came along quickly afterwards. He worked on his own equation, and then he realized, wait a minute, Balmer's equation is really just a special case of my larger, more inclusive equation. So Rydberg came up with the better equation that handled more than just hydrogen. And that's all I'll say about that, because I think I might use the next information in a further question. So Balmer was first. Shout out to Balmer, a Swiss mathematician and school teacher. But it was Rydberg who made the better equation. All right, see what happens. Oh, bold goat. Other than that, not much of a change. Goat being bold. All right. Oh, we got Brett making some uncertainty jokes there. Which of these series contains visible light? Sorry, I thought I corrected that typo there. So which of these series contains visible light? Again, this is a bit of a deep cut if you guys watched my videos this week. Do, 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 do. Oh, maybe not that hard of a question. Yes. So in tribute to the work of Johann Balmer, the bright lines that we could see, and I was going to make a question about this, but I didn't. But typically the transitions in hydrogen that are dropping to the second energy level are giving off light that we can see in the visible spectrum. The ones that are dropping down to the first energy level are into the ultraviolet. And then those are called, I think, the Lyman series. And then the ones that are dropping into the 3 or higher are into the infrared. And that's like the Passion and the Bracket and like some other ones. Good job. Nice job. Mountain Yak. Mountain Yak is appearing. Nice job, Mountain Yak. I don't hear the alumni talking trash anymore. All right, here we go. Bohr provided evidence that bright line spectrums were caused by, and I think I accidentally just gave this away in my explanation of the last question. Read those questions carefully, or those answers carefully. I'm going to cover these answers up so you can't see them. Okay, so no, listen, that's a reasonable mistake to make there. So almost all of you chose between electrons jumping up and electrons descending. Now, both of those are needed, but think about it now. The electrons must get excited first. Remember, the electron is in its ground state, its lowest state. And so when it gets hit by electromagnetic radiation of a certain frequency, it gets excited up to a higher energy level. And it is only then it can fall back down. And since energy needs to be conserved, that is when it emits a photon. So the electron does not give off light when it jumps up. It actually needs to absorb electromagnetic radiation to do that. It's just like a kid climbing up a slide. You can't slide down a slide unless you've climbed up the slide. So it needs to gain the energy to jump up to a higher energy level, but it emits the photons when it descends. And if it descends the right distance, it gives off the right energy that we can see. But it's always giving off energy. It's a matter of, can we see it in the visible spectrum or not? If it's higher energy, ultraviolet. If it's lower energy, infrared. If it's visible just right, we can see it. So again, that's a legitimate mistake to make, but you've got to lose energy to give off photons. Anyway, nice try. Oh, Nika, are you getting these wrong? Oh, we got this classic 5 up here. Man, this is not budging here. I guess since we're not having the Olympics this summer, this will have to take the place. By the way, no, we didn't. Some of this stuff, yeah, that's true, Lucy. I have gone into more details. We did anecdotally talk about Bohr transitions, but I've gone a little bit more into detail. That is true. I've dug a little deeper. By the way, if you like these Friday Kahoots, I'm okay doing these. I think this is kind of fun. It's a nice break. So just in the chat as we're going along, if you like the idea of a Friday Kahoot to kind of review the stuff for the week, feel free to let me know in the chat right now. All right, here we go. 12 of 20. All right, Louis de Broglie proposed. There he is, Louis de Broglie. Luke, this might be the last quantum Kahoot. I got quantum numbers and stuff coming too. So there's still the ramifications coming. Man, Louis de Broglie. This guy was a legend. By the way, oh, very good. Nice job, everybody. Yes, matter could have wave-like properties. Exactly right. Yeah, remember, he flipped Einstein's ideas on their head. Einstein said that light could act like maybe a particle, hence the idea of photons. And de Broglie said, okay, well, maybe everything has wavelengths, right? And so, and that would get him the Nobel Prize. And he got that for his doctoral thesis, which is pretty amazing. A lot of these people who won these Nobel Prizes this time were very young, not that much older than you guys. So, get to work. By the way, in the video description, I have a lot of really, 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 really good enrichment links that I don't think people are watching because in the past I've thrown some pretty funny red herrings in there. No one said anything, but these are all serious ones in today's video. And one of them is an interview with Louis de Broglie, like back in the 60s, which is kind of cool. So anyway, so yeah, great, important idea here. All right, let's see what happened here. Snowy crab. Snowy crab. All right, nice job there. Here we go. 13 of 20. Man, Kahoot Premiere, man. What was Schrodinger's most important contribution to quantum mechanics? Quanthoots. That was funny. I like that. By the way, it's in the chat. Let's see if you can name those 4 fellows. I'm not sure who the guy on the left is, but I can name the other 3. I think. Very good. His wave function equation. Yes. Yes. Wave function equation. Very good. Nice job. Yeah. So that was the idea that, that was the most important thing Schrodinger did. Obviously, he didn't do the Rydberg equation. That was named after somebody else. His hatred of cats. I don't know if he hated cats or not. That was that thought experiment of his to show the absurdity of probabilistic quantum mechanics. And again, he didn't do the uncertainty principle, but stay tuned. We might have a question about that. Hey, Luke, you wrote a song about science, right? You should plug your song about science. Put a link in the chat. If I remember correctly, Luke wrote a song about science. So you should check that out. Everybody, I'm going to plug Luke. Anyway, so feel free to advertise your song in the chat. All right. Anyway, if we can't self-promote, what can we do? All right. Stellar Gorilla. Nice. All right. Here we go. Schrodinger explained Bohr's allowed energy levels by using standing waves. True or false? Look at this. I found a picture of a dude standing and waving. Get it? Does that guy kind of look like Brett? A little bit. Whoa, look at that. Crushed that. Yeah, nice job. Very nice job. What do you think? A little bit like Brett? A little bit. Anyway, all right, here we go. All right, let's see. I wish I could find out how my new students are doing against my alumni here. New students, how are you doing? New students, let me know if you're in the top 5, right? We need to show these alumni that they are out of shape when it comes to chemistry here. All right, here we go. Only a couple left. Oh, good, Madison. Good job. Who squared the wave function to create a probability distribution? This is definitely only for people who watched the video this week. I chuckled when I wrote that. That was funny. Are you looking this up right now? Who's looking this up? Stop cheating. This guy doesn't get enough credit. It was Max Born. Yeah, that was Alfred Nobel. G.P. Thompson. No, G.P. Thompson actually G.P. Thompson validated some I think he validated the duality of light. And Dirac was a cool dude. Yeah, you should definitely read about Dirac. Dirac was a very, very cool fellow. A lot of these quantum, I'm telling you, there was a lot of like politics and like, I guess, just a lot of weird sort of like social things going on in quantum mechanics. There was different camps and they were all like cliquey. And, it was definitely, the history of quantum mechanics is very fraught with a lot of like infighting and stuff and a lot of characters and it's just neat stuff. So you should check it out if you're interested in realizing that scientists are people too. So that was Max Born. Congratulations, the 4 people got that right. Let's find out. Wow, it must have been those people at the top. Bold Goat, Mountain Yak, Kind Lizard. Bold Goat. Is anyone self-confessed to being Bold Goat right now? Man, woo. Good job, Lucy. I'm glad you're turning into my size class. And Lucy, yes, your picture is still up in the classroom. No one's looking at it now because of the pandemic. But anyway, what is the % chance of finding an electron in its orbital? This is a pretty easy one, I think. Stay tuned after the Kahoot for Terrible Art Improv. Luke, don't forget to put the link for your song in the chat if you're allowed to do that. Very good, 90%. Yeah, remember that the whole idea of this is that Bourne figured out that there was sort of a probability density of where you could find electrons. And to kind of like tame that a little bit, they ended up putting like a 90% cap. So when we start talking about quantum numbers and the shapes of orbitals, just understand that those like hard shaped, those things that look like they have a really hard edge, that's sort of a compromise of saying, okay, here's the 90% region. So it looks like this solid body, but that's sort of a mathematical compromise of probabilities. So it is what it is. All right, Bold Goat. Woo! Oh, good. Here we go. Good. Luke's going to share. Check out that song. It's pretty good. It's pretty good. A lot of talent. A lot of talent in my students here, alumni and current. Who proposed momentum and position of a quantum particle cannot be simultaneously determined? Woo! Oh, Abby, it's okay. You're here, so you're better than the 90% of my students that aren't here. Right? Because I think we're like half alumni. That's okay. We'll show them next year. Very good. Heisenberg. It was Heisenberg's uncertainty principle. Remember, the cool thing about Heisenberg's uncertainty principle, what he was trying to point out is that, again, there was these different camps of quantum mechanics. And some people were trying to say they didn't like the idea of the probabilistic nature of quantum mechanics. And that was, there was a camp, I think it was Einstein and stuff, were really against that. I feel like it was Einstein was against that. And so Heisenberg said, well, no, I mean, it's, the reason we can't calculate this stuff isn't because our theory is bad, is because there's actually limits to what the universe can, so there's limits to what we can actually measure. There's no limit to our theory. It's just that there's a limit to the universe. And so that became what's known as like the Copenhagen interpretation, which remains, I think, the leading view of quantum theory, but there is still no consensus about why all this stuff happens. This is where we get into like the Copenhagen interpretation and like the many world interpretation, which is like literally like that really means like quantum mechanics happens because there are like multiple worlds that spring up, which is pretty cool. So, oh well. Hey, listen, Luke, just tell us the name of your song again, and I'm sure they could find it on YouTube or something. So if you just tell us the name, people can search for it themselves. Anyway, so there we go. So that was Heisenberg's uncertainty principle, not to be confused with Heisenberg from Breaking Bad. It always sort of annoyed me that that dude Walter White was a chemistry teacher, yet he chose Heisenberg, which was not really a chemist. He was more of a physicist. That always kind of burned me a little bit. He should have picked some chemist like Lavoisier or something, but it is what it is. Anyway, let's continue on. We have 3 questions left. Now, these are, I'll be honest, these are timely questions to see if you have been paying attention to the CDC. So let's see what we're doing here. Let's do some current questions here. What is the minimum length for proper social distancing? In meters. Haha, it's a conversion. Got you. Conversion. Got you. Yeah, that's right. Factor label. Let's see how you're doing here. Yeah, you forgot how to convert, didn't you? Didn't you? You're trying to look it up right now on Google, aren't you, you cheaters? Cheater McCheaterson. Yeah, 6 feet is about 1.8 meters. Yeah, so there you go. Sorry, haha. Now, listen, I've been reading, some people say, by the way, 6 feet is like the minimum distance. If you look it up, like some people say that was based on like studies from the 40s and 50s, but we're kind of stuck with it. But, that's the minimum distance, 6 feet. But you should probably be distancing even further than that because who knows how far a droplet can actually travel. And if you're showing any symptoms at all, you shouldn't be out at all. 10 feet's not safe enough, If anybody's showing symptoms, or any kind of dry cough or anything like that, fever, obviously stay at home. So there you go. See that? Okay, here's another one. Let's see. But obviously, I don't know. You think you guys should have done better. This is not. You guys failed the social distancing question. Here we go. Let's try again. Epic Penguin making a move. Here we go. Let's try again. The CDC recommends that you wash your hand for a minimum of prefixes. Yeah, that's right. Prefixes. Yeah, prefixes. Metric prefixes. Yeah, deciseconds. Uh-oh. Uh-oh. Someone doesn't know their metric prefixes. Start getting ready to spam the chat, by the way, for your improv art. Oh, you guys did it. That's pretty good. Nice job. Yeah, decisecond is 10th of a second, so you would need 200 deciseconds. So good job. Nice job. All right, we have one more. One more. This is not a CDC thing here, but let's see if you've been paying attention this week. Last question here. Mr. Anico has recommended you check out. So what should you be watching? What have I told you that you should check out? Let's see, who's been paying attention? You're trying to look it up right now, aren't you? Oh, nice job. Very good. That's good. Yeah. Yep. There it is. Yep. So Flynn Live Lab. So again, if the Feynman, like, you should definitely, I did recommend you check out the Feynman lectures, actually. Yeah, you should definitely check out anything by Feynman. He was a legend. The Flynn Live Lab, again, if you are at all curious in maintaining or, watching some science stuff, Flynn Scientific, which is a great chemical company that I order from occasionally, they are doing a live stream at 2:00 in the afternoon. And it's good. It should validate what you've learned about chemistry or teach you some new stuff. It's a little rough around the edges, just like my stuff is, but they are using Zoom, and that has the ability for they do live surveys and you can ask questions and things like that. So if you are looking for something to have running in the background, I think, again, we should all be supplementing a little bit. We are really doing minimum coverage right now. So anyway, so let's see how we did here. The podium is up. Congratulations. Let's see. I think it's pretty obvious. Epic Penguin, 3rd place. Nice job. Please feel to say, Mountain Yak. Congratulations, climbing the mountain. And here we go. No surprise here. We got Bold Goat. If anybody would like to self-admit to being Bold Goat, feel free. Congratulations, Bold Goat. All right, so there we go. Nice job. We'll get the feedback here. Again, feel free to shout me down. That's fine with me. I'm happy. I eat your disapproval for breakfast. It powers me up. Just like in Red Dawn, all that hate's going to burn you up. It keeps me warm. In fact, if you're looking for movies to watch, by the way, in the pandemic, one of my favorite movies of the 80s, Red Dawn. Great movie from the 80s. Great one-liners. Yeah, so that's my 80s movie recommendation. That was a great movie. So there we go. Oh, you guys are being kind. Thank you. Lindy, congratulations. Congratulations, Lindy. Bold Goat. A big win there. All right, so here's what we'll do then to wrap up today. Don't leave yet. What we'll do, hold on, let's get this back up. Let's switch here. Hold on to my different stream here. Hold on. Let's make that visual. And let's switch over. Look at me. Who knows how to do OBS? This guy who's got 2 thumbs and knows how to use up. That's it. I can't do thumbs. All right. Thank you, Ab. Yes. I've been trying. I've been trying to work at this up here. All right. So thank you. I appreciate that. Spread the word. All right. Draw Bold Goat. I think that is an absolutely fair. A Bold Goat. I can do that. Your Chipotle order. I see. All right, let's see. I'm not going to draw. I won't draw Brett only because if it looks terrible, I don't want that to be like stuck on the internet. So I think I drew a squirrel. Oh no, I didn't draw a squirrel. You know what? I'll do a hazmat suit. That's what I'll do. Okay. All right. Let's see. I can do a goat. Let's see. So here's a goat. There's some excited kids upstairs. I feel like goats are pretty easy to draw there. I don't know. There's some goats. Got some goat legs. Ooh, it's got some weird goat legs there. Can't go back. No erasing. Here's goats have horns, right? Goats have horns? I feel like goats have horns. Oh, no erasing. You're just going to have to take this what it is. Goats have like hair on their chin, right? There's a goat. Sorry about that goat leg there. And then we'll draw Brett in a hazmat suit. Okay, so here we go. So we'll get a Here we go. I can draw a hazmat suit. You guys are all, this is all on my skill sets here. So there's Brett. And, oh, he should have had his hood up. He doesn't have his hood up. And there he is with his gloves. Oh, no erasing. Can't erase. It's a little puffy because it's a hazmat suit. Zip. There he is waving. There we go. Some excited kids upstairs. There you go. There's Brett in his hazmat suit. There you go. See that? So, anyway, so that's the Terrible Art Improv for today. Thank you, Nico. I appreciate that. Hyun, hello, Hyun. How you doing today? I have a material science midterms. Okay, well, good luck. Good luck, material science. Choose C. Oakleaf, everybody. Check out Oakleaf's channel, man. This guy is a YouTube inspiration for me, man. He's got some views, man. He's a master of a lot of production. I'm expecting him to keep maybe some behind the scenes video, some blitzball behind the scenes. Quite talented. So anyway, good luck, everybody. What we'll do is check out the weekly assignment sheet. It's not up yet, but you can start to see what's due on the Blackboard calendar or the Pearson calendar or the long-term assignment. I've pushed some stuff back to next week. Remember, we only have 2 days next week because of spring break. Woo! Quarantine, spring break. Yeah, so just like the old times. All right, anyway, so if you have any questions, make sure you email me. Let's get out of here, everybody. Thanks for watching, and have a great weekend. Go outside, enjoy some sunshine, but just keep that social distance at least 6 feet.